All right, let's get right into it. Have you ever written a Python script and it just felt kind of stuck? Like it's trapped in its own little bubble? I mean, it can do all this amazing stuff internally, but how does it actually reach out and, touch your computer's files, its folders, its settings? Well, that's exactly the puzzle we're going to solve today.
So yeah, that's the big question, right? How do we break our code out of that box? How do we give it the power to navigate your whole file system, read system settings, and even respond to commands just like a real application? The answer, it turns out, is in two incredibly powerful built-in Python modules.
And here it is. This is the single most important idea to get your head around. Just think of it like this. The OS module is your script's key to the outside world, all the files, the folders, the environment around it. And the sys module, that's the control panel for the inside world. It manages the script itself while it's running. Outside versus inside. Simple as that. Let's see what that really looks like in practice.
Okay, first up, let's unlock that outside world using the OS module. This is basically your toolkit for making Python act like you're a power user sitting at a command terminal, giving you complete control over the file system.
Navigating your computer from inside a script is way easier than you might think. With os.getcwd, you can literally ask, hey, where am I right now? And it'll tell you the current working directory. os.chdir, that's just like typing cd in your terminal. It lets you jump into a different folder. And os.listdir is like typing ls or dir. It just shows you everything in your current spot. It's like your script is doing the typing for you.
And it's not just about looking around either. You get total control over the lifecycle of a directory. You can create a brand new folder with os.mkdir, you can change its name with os.rename, and then, when you're all done with it, you can just get rid of it with os.rmdir. This is exactly how you can automate things like setting up new project folders or cleaning up temporary data.
But here's a classic trap that gets everyone. You write this perfect script on your Mac, using those forward slashes for file paths. It works great. Then your colleague tries to run it on their Windows machine, and boom, crash. The whole thing breaks, all because Windows uses backslashes instead. This one tiny difference can make your code incredibly fragile. And the solution is just beautiful. It's this one elegant, simple function, os.path.join. You just feed it the different parts of your path, like the folder name and the file name, and it automatically uses the correct slash for whatever operating system the script is running on. Mac, Windows, Linux, doesn't matter. This is the secret to writing code that just works anywhere.
Now, OS isn't just about files and folders. It also lets you tap into something super important called environment variables. Think of these as system-wide settings, like secret API keys or database passwords that live outside your code for security reasons. Using os.environment, your script can safely grab these secrets without you ever having to hardcode them. Super, super useful.
Okay, so that's the outside world covered. Now let's flip the coin and talk about controlling the inside world. The sys module is all about managing your script while it's running. What arguments it gets, how it exits, and even its relationship with the Python interpreter itself.
So imagine you want your script to be flexible, to process different files each time it runs. Well, instead of changing the code every time, you can just pass information directly to it from the command line, like this. We're basically telling our script, hey, use input.txt as your source and output.txt as your destination. But how does the script actually get that info?
Well, that's where sys.arg comes in. And honestly, it's just a list that Python makes for you automatically. The very first item, at index 0, is always the name of the script itself. Then every single thing after that is one of the arguments you typed, in the exact same order. This is the fundamental building block for pretty much every command line tool you'll ever write.
So what happens when your script finishes? Or what if it hits an error halfway through? With sys.exit, you can have your script tell the operating system whether it succeeded or failed. An exit code of 0 means all good. A non-zero code, usually 1, is the universal signal for something went wrong. This is absolutely critical for automation because it lets other scripts and tools know if your script actually did its job. And the sys module is also kind of like your script's identity card. You can use it to check exactly which version of Python is running, what the operating system is, like Linux, Win32, or Darwin for a Mac, and even where the Python program itself is located. This is incredibly helpful when you're trying to debug weird compatibility problems. So, we've got OS for the outside and sys for the inside. This is where the real power kicks in, when you start using them together. Let's see how this duo powers pretty much all real-world automation.
I mean, just think about a backup script. It's going to use sys.argv to figure out which folder to back up. Then it'll use os.listdir to find all the files inside. It'll use os.path.join to build the correct destination paths. And when it's all done, it'll call sys.exit0 to report, hey, job's done, everything's good. From DevOps tools to data science pipelines, this combo is everywhere.
So let's just put it all side by side one more time to make it super clear. The OS module, its focus is the file system and the environment. It handles things like directories and paths. The sys module focuses on the interpreter and the script's runtime, handling things like arguments and exit codes. They're really just two sides of the same coin, giving your Python scripts total control.
So after all that, what's the one thing, the one big idea you absolutely need to remember? It's all about unlocking a whole new level of power for your scripts.
Here it is. This is the master key, the one thing to burn into your brain. If you are dealing with files, folders, or environment variables, anything outside your script, you need OS. If you're managing how your script runs, the arguments it takes, or how it exits, the stuff inside your script, you need sys. OS for the outside, sys for the inside.
So, now you have the keys to both the inside and the outside worlds of system scripting with Python. You can build powerful tools, you can manage files, you can create some seriously impressive automation. The only question left is, what are you going to build first?